Okay, question number 1. Use the equation f of x equals negative x minus 2 cubed to find the y-intercepts of the graph, find all zeros, find the domain and range, and then you're going to graph it using the y-intercept and the x-intercept. So to find the y-intercept by hand, you would want to take this negative 2 right here and cube it. So negative 2 cubed equals negative 8. But you also have this negative right here, so once you take that negative and multiply it by the negative 8, you get an 8. So the y-intercept is 0, 8. So if I put that on the graph, 1, 2, 3, 4, 5, 6, 7, and just right above it. Now, I'm going to find the zeros. So you always want to start at the parent function's point of inflection. It's right there in the middle. And then this graph tells me here I'm going to move it 2 places to the right. So remember, even though it looks like it's a negative, a positive 2 was actually substituted in. So I start at 0, 0, and I move 2 to the right. So that is my 0. So my 0, or x-intercept, or root, or solution is 2, 0. Okay, for the domain and range, you're always going to have the domain for these cubic functions. It's always going to be negative infinity to infinity. Now this is written in interval notation. So here, if I kind of sketch it, you can kind of tell that it's going to always go up and down. Also notice, because of the negative here, that it's falling down like a line, falling down. Now, for the range, again, because it's always going up and down, just like for the domain, it's always going up to the left, down to the right, this will also be negative infinity to infinity in an interval notation. You can also write it as an inequality, and you are expected to know both of these. Okay, for the next one, you're going to match the graph below with their corresponding functions. So looking at the first one here, it says negative x cubed minus 2. Now this last number right here is your y-intercept. I also notice that this negative is going to make it go down. This one is going down, this one is going down. Notice how this one's going up, this one's also going up, this one's going up, and this one's going up. So because of that negative, it has to be one of these two because it's falling. Also, this is your y-intercept, so I notice that this one right here also crosses the y-axis at negative 2. So number 1 is graph D. Now here on 2, again, you always want to start with that point of inflection, and I can tell that this is going to move 2 right and 1 up. So I'm going to go through each of these and see which one moves 2 to the right and 1 up. Well, first of all, this one's a positive, so I know it can't be one of these because it's negative. Here, this isn't moving 2 to the right, it actually moved 3 left. This one didn't move at all. This one here, again, you use that point of inflection. If I move over 2 and go up, there's the new point of inflection. So for graph 2, you have E. Alright, and this one here, again, that point of inflection was moved 2 to the left and 1 up. So I'm going to go look at each graph and see which one was moved 2 to the left and 1 up. So again, start at the origin. Now this one is still falling, so that can't be it because this is a positive A. Now here I notice if I move 2 to the left and 1 up, there's my new point of inflection. So 3 is B. On 4, notice how you can write a plus 0 at the end. That's your y-intercept. So my y-intercept is going to be at the origin at 0, 0. So it would have to be one of these graphs. Also, this fraction here tells me it's a compression. So it's going to look a little wider. So this one, you'll notice, looks a little bit wider than this one compared to the parent function. So 4 is F. On number 5, again, it says 3x squared. You could also pretend that there's a plus 0 there for the y-intercept. And it is a stretch because of the 3. And so this one here does look a little bit skinnier than that parent function, so 5 is C. Now this one, again, you'll notice that it's a negative. Oops, sorry about that. I didn't realize that wasn't on the screen. Okay, so here, this one is a negative. So because of this negative right here, it's going to be falling down. So this one is falling down. And also notice that it's moving 3 to the left and 2 down. So if I come over here and I move 3 to the left and 2 down, there's the new point of inflection. So 6 is A. Okay, on number 3 it says graph the equations below and state the x and y intercepts in the domain and range. Now again, the domain and range on every single one of these is going to be negative infinity to infinity. Now I'm going to write it in interval notation. And I think this one over here I'll actually write in as an inequality, just so you understand the difference. Okay, so again, for my y-intercept here, I actually need to do this again, where I take this negative 2, and I cube it, and that gives me negative 8. But then I also add the 3, and that gives me negative 5. So here, I know that my y-intercept is 0, negative 5. So I'm going to come down here, put 0, negative 5. That's my y-intercept. Okay, and then here again, this is how your point of inflection moves. So it starts here at the parent function, 0, 0. It moves 2 to the right and 3 up. So it would be best just to kind of sketch a curve through that. And it'll look something similar to this. Now I'm not going to worry about the x-intercept. You can always look at your calculator to see that. Okay, on this one here, again, for that y-intercept, I'm going to do negative 4 cubed. That gives me negative 64. Now again, because of this negative 64 will actually turn into a positive 64, and then plus 2. So that gives me 66. So my y-intercept is 0, 66. I'm not going to be able to fit that on here just because it's so large. But what I will do though is I will put the new point of inflection. So again, I'm going to start at 0, 0. I'm going to move 4 to the right and 2 up. And then again, I know my y-intercept is going to be somewhere like way up here, so I'm just going to try to sketch a pretty good idea of what it's going to look like. And again, notice that this one is going down because of that negative, that reflection, okay? And the x-intercept again, I'm not going to worry about that. You can always look at your graph. I mean, you can tell here is going to cross somewhere between 4 and 5. And then this one here is going to cross somewhere around there, okay? All right, the next one says describe the transformations that have been applied on the function f of x equals x cubed to create the function g of x equals 4x minus 6 cubed plus 2. Now remember, this 4 here is what tells you if it's a stretch or a compression, and also if it reflects across the x-axis. Now this is a positive 4, so it does not reflect across the x-axis, but it is a vertical stretch. By 4. Now, everything that happens in the parentheses is horizontal. So this is actually a horizontal shift. And be careful here. You know, you want to say that it's a negative here, but it's you want to say that it's moving left because you see the minus 6, but it's actually moving to the right 6 places. Now, everything on the outside is again vertical. So this is a vertical shift 2 units up. Okay, on the next one it says state the zeros. So again, y'all, you've got to make sure you understand that the zeros are the same thing as your x-intercepts. And they can also be called the roots and the solutions. So it's kind of hard to read the graph. I'm pretty sure it's counting by ones. So for this one, this is x would equal negative 1. Here, x would equal positive 1. And on this one, looks like it's probably 3, x equals 3. Now, on the next one it says state the domain and range in interval form of the graph below. Now for the domain, this thing will always go left and right. So your domain in interval notation will be parentheses, negative infinity to infinity. And then my range, remember that's from low to high. This is the lowest the graph will go, right here. It looks like to be about negative 8. There's your negative 10. I'm going to assume that it's counting by 2s. Okay, so again, you always want to write it from low to high. So the lowest this graph will go is negative 8. Again, I'm using a bracket because it's a closed dot. All the way up to infinity because it'll go up forever and ever and ever. All right, the next one says the graph of f of x equals x cubed minus 4x squared minus x plus 4 is shown below. Write the set of all real solutions of the function f of x equals 0. Again, f of x equals 0 is the same as y equals 0, which is an x-intercept. And again, just like we talked about earlier, your solutions are just your zeros, your x-intercepts, and your roots. So here, I can tell that it's going to be x equals negative 1. On this one here, you're going to have x equals 1. And on this one, x will equal 4. Now, I know this question doesn't talk about the y-intercept, but do notice that this is where it crosses the y-axis. So that is your y-intercept. So your y-intercept is 4. All right, on this one here, you're just filling in a table to describe the transformation. I'm going to use the same values from the parent function. So negative 1, 0, 1. And basically, I'm just going to substitute it in to find my y value. So here, negative 1 minus 1 is negative 2. Negative 2 cubed is negative 8. Plus 4 is negative 4. I'm going to do the same thing with a 0. 0 minus 1 is negative 1. Negative 1 cubed is negative 1. Plus 4 is 3. And then here I'm going to put in a 1 this time. 1 minus 1 is 0. 0 cubed is 0. Plus 4 is 4. And notice how it kind of stays with the same pattern. Got the negative, and then the positive, and the negative, and the positive. All right, your transformations. Again, it says minus 1. So that's actually going to be a horizontal shift 1 right. Okay. And then this is a vertical because it's on the outside. So this is a vertical shift 4 up. All right, on all of these here, they want you to describe the transformation from the parent function x cubed, and they also want you to state the domain and range and the point of inflection. Okay, so what I'm going to do is, because the domain and range is the same on every single one, I'm going to go through and I'm just going to write the same domain and range over and over again because it's going to be the exact same thing every time. The only thing that's going to be different is how we ask it. Sometimes I'm going to ask for it in interval notation, and sometimes we're going to ask for it as an inequality. So here, these first ones, I'm just going to write as interval notation because it's definitely the quickest one. And again, you'll need to do this for the multiple choice and the open response. Here I'm going to switch into inequality just so you can see both of them. Okay, so that's the domain and range. Again, as an interval notation and as an inequality. Okay, so the next thing I want to talk about is talk about the point of inflection. I'm just going to call it the POI. So again, it's always moved from that parent function 0, 0. Okay, so I can tell that this one was moved 4 to the right, but then it wasn't moved anywhere else. So I know that the point of inflection then is 4, 0. This one here, again, this one just flipped and it was a stretch. So on this one here, the point of inflection moved from that 0, 0 just up 2. So here I know my point of inflection is just going to be now at 0, 2. Down here, again, my point of inflection, it was moved 3 to the left and 1 down. This one here, my point of inflection was moved 7 to the left, and it didn't go anywhere else because there's nothing here. So my point of inflection here is going to be -7, 0. Now my point of inflection here, notice how I don't have any sort of y-intercept back here, it's just a +0. So for this point of inflection, it's literally just going to stay at the origin, so 0, 0. On this point of inflection, again, everything is moved from 0, 0, from the parent function. So this says -3, that's my y-intercept, so it just went down 3. So my point of inflection here would be 0, -3. All right, now let's talk about the transformations, just looking at the equation. So here I know it's a negative, so that means it's a reflection across x-axis. I also know it's going to be a vertical compression because it's a fraction. Again, those rhyme. Compression, fraction. And I see something's happening on the inside, so that's my horizontal. So this is going to be a horizontal shift 4 to the right. All right, number 11. Again, I see that negative, so I know that's a reflection. Across x-axis. I see the 3, that tells me it's a vertical stretch. By 3, just like this was a vertical compression. I forgot to put that. So this is a vertical compression by a half. By a half. Okay, now I can also tell that this one moved up. So this is a vertical shift. 2 up. Okay, on number 12, I don't see anything happening for the reflection or the stretch or the compression, so I only see something happening on the inside. So again, that's your horizontal. So it's a horizontal shift 3 to the left, okay, 3 to the left. And this one is a vertical shift 1 down. All right, number 13, it's a +2, so it's not a reflection. So because it's a 2, this one is going to be a vertical stretch by a factor of 2. And I also have something happening on the inside, so remember that's your horizontal. So this is your horizontal shift 7 to the left. All right, number 14, I do see a negative. So again, that tells me it's a reflection. So a reflection across your x-axis. And it's also a fraction, so that tells me it's a vertical compression by 1/3. All right, the last one. Again, I see a 2. So this is a vertical stretch by 2. And it's also a vertical shift down 3. Okay, on the next one, it says find the real solution. So remember, your solutions are just your zeros or your x-intercepts. So really what I'm looking for here is I'm looking for where each of these cross the x-axis. Now you can always look at these on your calculator, but sometimes it's easier just to kind of look at the parentheses. So basically what I'm going to do here is I'm just setting each of these equal to 0. So for instance, this one's already done for you, x equals 0. Now this one, again, if I set it equal to 0, that means x would have to equal 3. So far I know this crosses at 0. It's going to also cross at 3. And again, if I set this one equal to 0, I know x has to be negative 2. So this one will actually cross the x-axis 3 times, at 0, 3, and negative 2. Now this one, again, if I just look in the parentheses, I'm going to set this equal to 0. And even though it says it's cubed, you really only have to do it one time. So I can already kind of tell that this one's only going to cross one time. So this one would be x plus 3 equals 0. So x equals negative 3. And again, you can always check these in your calculator. So if I were to come to my calculator here, and I were to type in, get that so y'all can see it. If I were to type in the x plus 3 cubed, and if I were to go graph it, again, that's where it crossed at negative 3. And then also notice it's also your point of inflection right there. Remember, that point of inflection is that turning point. All right, on the next one, I actually have two things I need to look at here. So I have here and here. So again, if I just make that equal to 0, well, the only way to get 0 is so that it equals 0. So there it goes. I know it's going to cross at 0. And then again, if I set this equal to 0, x equals 4. So hopefully by now you're noticing that when it comes to the parentheses, I'm really just doing the opposite. This was a minus 3, so it's positive 3. This was a plus 2, it's negative 2. This was a plus 3, it's a negative 3. This was a minus 4, so it's a positive 4. And again, you can always go to your calculator, well, except for pre-AP, who has to do it all by hand. If I put in x squared and x minus 4 and I graph it, I should notice it's going to cross at 0, and then it's going to go back up, and it's going to cross at the 4. Okay, on the next one, again, I'm actually just going to do this one kind of more the shortcut way, since we just talked about it. So right off the bat, you should know that this is x equals 3. This is x equals negative 2, because all I'm doing is I'm taking the opposites, and x equals 1. All right, the next one. Now this one, I just want you to state the zeros. So again, that's just your x-intercepts. Really make sure you understand that. Of the functions below, and write their equation in factored form. So remember, that factored form is just with all those parentheses. So I'm just looking to get a whole bunch of stuff in parentheses. And again, it needs to be the opposite. So for instance, on number 20, I can tell that this one is going to cross at, and I think I've got my counting right. I think this is going to cross at negative 2. This crosses at 1. And this crosses at 3. So when I do my factored form, I'm looking for the opposite, x plus 2. That's a positive 1, x minus 1. That's a positive 3, x minus 3. Because again, if I were to set each of those equal to 0, I would get x equals negative 2, x equals 1, x equals 3. Okay. On the next one, I'm just going to locate where they're crossing. So I'm pretty sure that's going to be negative 3, and that is 0. Now, with the 0, it is a little bit different. So the 0 is just an x by itself. And then on the inside here, I'm going to have the opposite, so x plus 3. But then I'm going to square it, because it only crossed here. So this represents my 0. But then you have to have two x's here, because it's a cubic function. If not, it's going to end up being a quadratic. All right, the next one. Okay, this one crosses at 2 places. So for this one, this crosses at negative 1, and this crosses at positive 2. So here, I'm going to have x minus 1. I'm sorry, x plus 1, the opposite, and then x minus 2. Now, I also notice that this is going down, so I have to have a negative. But I'm kind of thinking, which one do I need to square? So I'm going to actually go to my calculator, and I'm going to type it in, and I'm going to square the first one first. And I'm going to see if it looks like this graph. Okay, and I just noticed I do need to insert a negative there because it was falling. So let me go back and look at that. Okay, so this one actually does not look similar. Notice how the y-intercept here is at -4, but this is like a positive y-intercept. So now I'm going to take that square off, and I'm going to put it over here. Let's see if we can get it to look like the graph. Now that looks more like it. See how the y-intercept is down here at -4, just like that y-intercept. So this is the one that I need to square. All right, on the next one, I'm noticing this crosses at -4, this crosses at -1, and this crosses at 2. So again, I'm looking for the opposite, x plus 4, x plus 1, x minus 2. And that's my factored form. So for these, just remember that these are your zeros or your x-intercepts, and to write it in factored form, you have to write the opposite. So again, these are my zeros or my x-intercepts, and that is my factored form. Okay, just some things to remember. Really pay attention to the negatives. So for instance, this is that parent function. Looks something similar to this. So this is that f of x equals x cubed. And notice how it's rising. It's going up, okay? But remember, if it's a negative, it's going to go down. Just notice how it's going down. That's something really important to notice. Also remember that point of inflection, that's your turning point. It's not always going to be on the x-axis. You could even draw a graph where it's up here. And I'm just going to estimate this. I mean, this could be your point of inflection, and it could be like -2, 1, okay? So just understand that that point of inflection is kind of like your turning point, and you can actually find it just by looking at your equation. So for instance, it's 2, 0, because I know it just moved over 2. Okay? All right, good luck on the test. I hope this helped you.